Okay, we are back. This is Calculus 1. We are looking at section 4.4, the mean value theorem. Typo right off the bat on page 10 of your chapter 4 note packet. In section 4.3, we learned about the extreme value theorem, in which the max or the min could occur on an endpoint. The French mathematician Michael Rolle gives conditions that guarantee extrema in the interior of an open interval. So again, for Rolle's theorem, it's let f be on a continuous function. So that means no holes, no asymptotes, no jumps, and a closed interval inclusive a to b, and differentiable, which means no corners and no cusps over the open interval, such that f of a is equal to f of b. Okay, so then there exists at least one point c in the interval ab, such that f prime of c equals 0. So the slope of the tangent is 0. There's a horizontal tangent somewhere. So there's a critical number at C. And so when you look at A, B, and C, the pictures here, they show this and this and this. And so we're talking f of 0 is right there. So that's a maximum. This would be a minimum. And there could be a max and a min on the closed interval. All right, so let's look at what this looks like with the function f of x equals x squared minus 5x plus 4. So page 10, it is continuous and it is differentiable. It says find the two x-intercepts of the function. Now remember, again, this is going back to your algebra days. X-intercepts, that's also known as the roots. Sometimes they'll call it the roots of the function, or the solution set. And so a second degree equation, remember factor and set them equal to 0 and solve. And so let's do it to it. So we've got, for example, 1, f of x is equal to x squared minus 5x plus 4. So we're going to set this equal to 0. We want to find the solutions, or where across the x-axis. So multiplies to be positive 4, adds up to be negative 5. That's got to be negative 1 and negative 4. That's equal to 0. And so now the only way we can get 0 through multiplication is if this is a 0 or this is a 0. So that's why we set them both equal to 0. Say x equals 1 and x equals 4. All right, so we've got 4, 0, and 1, 0. 1, comma 0 and 4, comma 0. That is where it crosses the x-axis. F of 1 is equal to 0, and f of 4 is equal to 0. All right. So that means our interval is from 1 to 4 inclusive. It's the 1 and the 4. Now it says find where f prime is equal to 0 on that interval, on 1 to 4. So now we're going to do the derivative, which again is pretty easy, right? 2x minus 5. And then we are going to set that equal to 0 because we want the tangent line. We want a slope of 0. So 2x minus 5 is equal to 0. You add the 5 over, you divide by 2. You got 5 halves, or 2.5 or 2.5. any of those. So we'll call it 5/2. That is a critical number. All right, so a CN, a critical number. And so this is in the interval from 1 to 4. So the way that we say that, we say 5/2 is an element. That's what this little, funky E looks like, epsilon, to 4. So 5/2 is an element of the interval 1 to 4 inclusive. All right? Okay, so the criteria that f be differentiable on the interval is critical to Rolle's theorem. So if you look at, they have an absolute value graph on the bottom of page 10. And Rolle's theorem would not apply because it is continuous, but it's f of -3. It goes from -3 to 3 inclusive. F of x is equal to the absolute value of x minus 2. But so f is continuous. F of -3 is equal to the absolute value, -3 minus 2, which is 1. F of 3 is equal to the absolute value of 3 minus 2, which is also 1. So f of A does equal f of B, which is part of Rolle's theorem. Check that off. But f is not differentiable. On the interval -3 to 3. So Rolle's theorem does not apply. All right. So let's look at page 11. Oh, wait, is that the next section? 4.5, the mean value theorem. Oh, that was a short section, 4.4. Just page 10. The next section is a long one, so look at that. Quick section. See you on 4.5.